Okay, we are live. It's very dark in here. Let me see if you can hear. Yes, very dark in here. You're unable to see me. I am in the shadows, and at some point I will turn on the lights, and we will be here for about 2 hours. I wish I can go faster, honestly. So 6:20, 2 hours. Yeah, I do like that. Hopefully we don't get any interruptions, so let's get started by opening our website that we are not using the thing. Hopefully today we managed to get something substantial. I mean, in the past days it has been a little bit of progress. Can't believe. Okay, we are back. So, uh, so we are live. So there was an internet interruption. Okay, but we are live. 2 hours. So we have this. Yeah, we have this. And now it is time for us to open the chalkboard. And yes, yesterday we managed to see this calculator. And somehow we were since we are neophytes in this trigonometry thing. We did have a hard time by making calculations using degrees, even with the book. Which book? This book says uses radians. Come on. Why do you want to use radians? Because of the range of the function. Which functions? The trigonometric functions. By using radians, you can enable the real numbers, the set of the real numbers, an insanely amount of numbers to be your range. Uh, After 1 hour, we finally find this thing. I was about to use Python. So the calculations, then we open JShell. Then we can click here. Designing a user interface is quite a thing. It is also, while you can design an intuitive user interface, you cannot think in advance on every usage. So maybe someone will say they should make this button bright a little bit. Yeah, then some other will say, and then make all of these be available. You can't foresee everything. So this is great. It's good design. Uh, it also corresponds to the user. It, the user should have the user should do a little bit of exploration of the user interface. All right. So you should take a minute and say, "Oh, deck, is this? Are you able to click this, or is this just a label? Maybe Yeah, it is a button, clickable button. Yes, we are not here to evaluate an option. Okay, then we have someone will say, guys, what's this? This is the length of the arc. Which arc? Well, we have we had some sort of unit circle. Okay, it was like this, right? And then this thing is as if you have this arc, which is what thing? Where is state? Um, there were also these arrows. We are going to use 90 degrees. So here is theta. Where is r? Here is r, the length. Then the coordinates. And then we have these two coordinates, x, y. And the book says that you can calculate x by applying the cosine. Applying the cosine. I am talking like a software developer, a programmer. So I'm applying functions to arguments. Cosine is the function. The argument is the arc length. I don't know the language of trigonometry. Maybe this is pronounced differently. Taking the cosine of s, as to say. But I'm just saying I am applying the cosine function to s. Okay, but maybe it is take the cosine, take the sine of s. I don't know. Eventually I will know and I will share it with you. And just in case you don't know. And then we have this. And then we perform some calculations. Since r is equal to 1, um, they say that in the unit circle, all this thing, or the unit circle, this equation simplifies to this equation. So now the measure of theta in radians is equal to the arc length, right? So we can forget about this. Now you know this coordinate, that's 0 and 1. Then 90 degrees, which is here, is equal to pi in radians over 2. And there were a formula. It says that you convert degrees to radians by multiplying the degrees times pi over 180. Why is this? It is up to you to look for it. Especially if you are 12 years old, 16 years old, 20 years old, like Oliver Heaviside said. And, just spend your day doing this. Is a good thing to do instead of any other activity that you think is great. For example, if you're playing video games 40 hours and feeling good about that, maybe I'm not criticizing you because I did it and I was happy seeing the statistics at the end. spending 60 hours finishing Symphony of the Night, Castlevania Symphony of the Night. Extremely great video game that I will recommend to you. Well, come on now, it's a lot of time, and it's great. So it's up to you. Uh, and now I am hesitating to spend 1 hour with this. Imagine that. Because I don't know if I am passionate about this. Uh, so okay, so even if you are late in your life, you can still put some hours into this and get familiarize yourself with this stuff. Not because you want to sound cool or you want to you know solve some you know I don't know. Just what I am saying this. Well, because of this. If you want to know why this formula exists, why is the case that this thing works, it corresponds to you to dig a little bit further. I will do it eventually, as I always say, uh, as I explore trigonometry. So where this thing comes from, it will be good for me to know. But if you are only in a hurry and you want some formulas already to work with, this is one of them. With this, we get 90 degrees is equal to pi over 2. So the book says that you can calculate x by applying cosine to s. S for the unit circle is theta. Look at this. It is in the book. I'm just repeating what the book says. I'm not taking any responsibility here. We are just seeing if this thing works. Okay, so now we are doing this to recapitulate what we did yesterday. Uh, um, we are about to say, yesterday we did have this degree. It was like this. I'm going to close this. Then you open your calculator and you find degrees. And then the book says, since this is zero, we are not interested. We are trying to find one. So it says sine of s. Sine of this. And then you grab your pi symbol, divide it by 2, and then you take the sign, let's say that, and then you find this number and you say, oh my god, this is not 1. And we did quite a detour. Eventually we click over here, radians, pi over 2, and then we take sine or apply the sine function, and we find 1. So the thing is working, okay? You can apply cosine. Let's apply cosine if we know. In order for cosine not to be left behind, and it's 0. So this thing works. And then, since we are sapiens or whatever, we say, will it work for this coordinate? Can we have a circle of radius 2? It goes like this. Whenever I see these figures, I think of radars, like the Dragon Ball, the cartoon series. I don't know, is it this anime series uh, to find the, how do you say in English, the spears of the dragon? Because it should be possible for you to come up with these ideas to find things in this stuff. Okay, zero, two. Now the radius is two. Where is radius? Now this thing, we have deleted the square or rectangle because now radius radius plays a role. Remember, we failed yesterday. We made a mistake or we didn't apply something, and we say, "Oh my God, we are so behind." Well, let's get ahead again and try to do the exercise again. So now these arc lengths, this thing, this thing, arc length of 90 degrees. I'm trying to find this coordinate. It should be 0, 2. So S is the angle is still this number, and the radius is 2. If you see videos on YouTube or training course, they do like this. Okay, this get canceled. Sometimes they explain to you why, sometimes they don't. But we are just deleting these numbers like this. They don't exist anymore because you are doing this. So their length is pi for uh, circle of radius 2, this thing being 90 degrees. Yeah, yes. Yeah, okay. So now it says pi, and these things say, okay, just apply cosine and sine, you should be able to find it. And now we should be able to say pi, find the sine, and you get 0, and it should be 2. Sine, apply the cosine, and it says -1. So this thing had found this point. Our formulas here, our formulas here, I cannot believe it, I cannot believe it. Yeah, this Veritas wall is such a thing. Now let me have 1 minute to see Veritas wall. That device, the apparatus, is used in a way that, oh my God, you will not believe it. As this guy says, it just amplifies whatever it's in the mind of the operator of the apparatus. The thing, the technology is an amplifier, as a lot of guys say, right? So you shouldn't be surprised if at some point you read the Verita worlds, see the characteristics of the people operating the apparatus, and then you will be able to see the results without you being a genius. Maybe you are a genius, that's great. But without too much thinking, you will say, oh, the results will be this because the people operating the apparatus are like this. We will have these results. Not that hard, you know? You will not do it. Unless there is another group, powerful, that put the things into balance again. Hey, come on, don't do that. That's nonsense. I don't know what will happen in that Veritas world. You know, uh, now enough procrastination. We found this. We found this point, and we want. Let me use this, and we want this, right? We want. I want this. Uh, but we found this. We don't want this. We don't want this color. We want this color. Uh, so anyway, um, now what we do, we can end the stream, go ahead and spend the day, you know, because now I don't know what to do. I don't have an idea on how to proceed. So, but remember, we were like this before. Don't think we will be in this. We will be in this spot for a long time. Remember what we have, and we were saying. We were making some annotations. We were rotating. Remember, we were rotating this straight edge, this figure, and making annotation. At 90 degrees, we have this number. 85 degrees, 45 degrees. Trying to find a relation. And we were lost. And what do we do? Then we have arrived to this. And now we can continue to explore this thing or read the book a little bit further, just some other pages, and move um, from this thing we have arrived from this spot. So what do we do? One, I think that if we are able to like uh, if we found this why this thing is not working, and what should we do in order for this to work? Then I'm going to erase this. If we know what's wrong in here and or what should we change, then we should be able to have this circle anywhere and find the coordinates of the points we want, given an angle. Or maybe we should explore this first and then come back here. Another uh, another consideration that we need to do is we are not going to start from these points. Uh, our straight edge origin is this point. So we need to find this point and we need to find its 90 degrees equivalent. So we are going to open from this side instead. But that's in the end. First, we need to see how this thing works, get a good grasp of these concepts. I think I got the unit circle, the very basic, at least how this thing works. But now we are moving ahead from the basics a little bit and start exploring what else can we, what else we can do in this. They also make mistakes. We are unable to delete this point, so don't feel bad. Oh, we managed to delete it. Okay. Mm, I think, this is like a test for a point, to see if a point belongs to the circle, to the, yeah, the circle. I think we should read a little bit further in the book because I, on my own, I don't know what else to do. If we use this equation, maybe these things change for a circle that it's not the unit circle. Maybe these change a little bit because in here what you can do is say, okay, zero, which is this zero, then y squared equals 2 radius 2, and then you find that this is the truth. But that's all about it. And if you change the equation for the other form for circles that are not centered at the origin, it will be the same. You just will be able to test for points. Mm, I think this these things change. Um, how much or how can you change this? Um, there are no equations here, just these two, in order for us to. In order for us to, to move. Hmm, yes, it should be. Because if you keep changing the angle, uh, the angles, yeah, converting from several degrees to radians, you will still find all of these points only. In the unit circle, these things change. So I'm going to open the book after half an hour and and see what's in the next pages. And remember, if the book does not mention anything that we can work with, changing this, then we are going to the resource that we found, open stacks, and rotation on the circle, and we can move and apply the things because now we made something. We have put some struggle, just a little bit of struggle into the thing. We weren't just asking for answers. And we can also try to understand the answer. Nothing wrong requesting the answer. You can request the answer and try to understand or request for an explanation of the answer. It's up to you and how you learn. So trigonometry, we were on page. Remember, it's very dark in here, but I'm able to read. You are not able to see me, but I am able to see a little bit here. Radian measure and the unit circle. This is the chapter 3. Look at this. I'm not bragging about this book. I'm not trying to sell myself as someone reading books because I bought this book 6 years ago and I just opened it this year, not the last year, one page, and then this year we put it. So I have the intentions, but I have some other books that I'm reading. But maybe I'll reach a point in which I finally commit sometime to this trigonometry. The speed of a planet revolving around its sun can be measured in linear and angular speed, both of which are discussed in this chapter. This is amazing. Okay, another internet interruption. Let's see, we are live. And yes, look, you can do all of this in your room, in the garden or courtyard or whatever you have available in your home or house. You can do so. Oh, we have one views. Hopefully, this person help us in the comments. Hey, here, where are the comments? Here, it's not necessary. But if this person knows and is wandering in the web, surfing the web, he can say, "Hey, come on now, this is the formula." Or if not, this person is just checking out. That's great. Thank you very much. And okay, so it says live replay here. I don't know what's this. Randomly playing the guitar. I think I will play the guitar again live for you. Hmm. Radiance, radiance means and then there is a circle with several radians. Measures angles, several angles marked. And maybe someone will say, why don't you just read these things offline and come back and make a showcase live of the things you have read? I'm going to move the computer. I'm going to turn on the light. This is nonsense. Just allow me a minute. I don't want to turn the light at 5 p.m. 5 better shot. Read from read this thing an hour. Come back. I don't know. I was remembering how I was for a long time trying to understand or educate or how to say patch. I, so maybe I can end the stream and come back. But no, I said that I would do it live, so I would just. Um, Maybe we should go directly to see the answer for this stuff, and then on my own educate myself with these topics. Well, there's no meaning doing this. Maybe it's just pretension. I don't know. But then someone will say, then use vibe coding or whatever thing, whatever uh, code editor assisted by artificial intelligence and deliver the thing in 3 hours instead of doing all this human journey. Uh, um, or maybe put the title programming like in the 90s or the 2000s. Old-fashioned programming. Not like old-fashioned coding because programming will be programming forever. It's not coding. It's not prompting. It's not even building applications as silly as it sounds. Video games or web applications or whatever you have. So programming will stay with us forever as long as we don't give away our thinking ability. I'm just waiting for the thing go a little bit darker so I can turn off the light. But don't feel bad about myself. Because I think I like natural lighting. That's the most you can afford. I can afford. Not because of the cost, because I like the natural things better, or natural things the most. So natural lighting actually is very it's quite a thing. So if you are designing offices for your workers, uh, find a way to design the building with natural lighting into account. Just just a minute. Just a minute. Yes, I will be here 2 hours. But since I was idle for 20 minutes, just like this, maybe 2 hours and a half, just to, balance the thing. What should we do if we want to do this by ourselves? Why this thing does not work? If the book says that this is S, these are length, it says circle. It doesn't say unit circle. This thing should work. Uh, but the angle is not changing. It's 90 degrees. So I'm not sure if for a circle this big and a circle this big and a circle this big. It seems silly, my thinking. The arc length will be the same because it's 90 degrees in every case. Like like the pi number, which I don't know, I don't remember, but it is a constant for all the circles in the world or in your brain. So I'm not sure if this is the same the length, but it shouldn't be. This looks bigger than this length, but the angle is the same, so maybe it plays a role. Hmm. Mm. Okay, let's turn on the light. Just a minute. Okay, we're back. Okay, we got us in the. So we are live, and I said, I hope get, I don't fall asleep. I hope I don't fall asleep while reading this book. Now look at me. I should be playing video games, you know. But I like this thing. I like this. To be honest, it's a little bit of different activity. Arc length of a circle. The formula for finding the length of an arc of a circle follows directly from the definition of an angle, theta in radians. Hmm. 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 Okay, so we were trash talking that book, the geometry book, but uh, we weren't trash talking that book. I love that book. We were saying that we will need some more advanced, not more advanced, a different branch of mathematics, or augmented with new discoveries. But it says that the lengths of the arcs are proportional to the measures of their central angles. I remember that book defining what's a central angle. I'm going to convert 90 degrees times 5. Yes, I don't know what's happening here. Mm, this isn't radians. The book says that this thing is in radians. That this should be in radians. It put a lot of emphasis on this being in radians. So let's suppose we have 3. And this thing will find this because we saw this yesterday. Fine. You see? Minus 1 or 2 pi. No, it's fine. If you like an entire rotation, and an entire turn of this thing. So it only works for the unit circle. Okay. So it says hmm, when the formula S equals radius times theta is applied, the value of theta must be expressed in radians, not degrees. We said that, we found that. A circle has radius, and then there are some problems. A circle has radius 18.20 centimeters, and the length of the arc is intercepted by a central angle. Yes. So there are more. There are more. Let's try 10. 10. A radius 10. 10, 10 times pi over 2. This thing should change. Now we are convinced. No matter how you extend the radius, these things will always give you 0 and 1. So something has to change here. Since I don't know I don't have any more data to play, more variables, more equations here. Uh, we have to look in the book. But now we are convinced. Oh my, that pronunciation again with this I. Convinced. 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 There you have it. Not convinced, convinced. But don't feel bad. These the native speakers of any given language do have problems with pronunciation, sometimes with certain words. I was seeing an interview of this guy, Ace Frehley. Now, he's from Kiss. He's dead. And they were arguing with some interviewer, is it pronounced Mankato or Mankato, some city of the United States of America. So they don't, every native speaker uh, perhaps have some challenges with pronouncing certain words in their own languages. So don't stress out about if you have some mispronunciations while learning a language, you know? So it's Mankato or Mankato, I don't know. I was seeing interviews from this guy in the past, many years ago, and many other people trying to learn from them. Lots of interviews instead of doing mathematics, right? What a waste of time. Well, it's not a waste of time. It's, I don't know, just trying to learn something from different points of views. But it's a better idea, I think, to devote yourself to mathematics instead of some perspectives. As long as you equip yourself in the mind with, avoid being manipulated or cheat or betrayed, which is hard. As long as you equip yourself with the right books, the right knowledge, you will be okay. And believe that bad things can happen to you. And we arrive again to the unit circle and the circular functions. And then we have a lot of radians associated with different arc lengths. For example, the quadrant one real number. The quadrant one real number pi over t is pi over 3 is associated with a point in the unit circle, so they should say. Well, I don't think this is the case. Pi over 3, 60 degrees. Well, let's see this. Pi over 3 and then apply why do I have hmm. You see these things change, but only for the unit circle. You have radius of 2, radius of 2, that will be 2. No, so pi over, so this is for 60 degrees, and if you multiply by 2, you get 2 times pi over 3. Okay, it moves the thing over here. It was like here and move it over here. No, Mm, no drastical change from what we have found so far. Note, because cosine of s equals x and sine of s equals y, we can replace x and y in the equation of the unit circle and obtain the formula. The Pythagorean identity. Pythagorean identity. In the case you want to know, because you are not reading the book, in the case you want to know what the book says, it says that x equals cosine of s, y equals sine of s in the unit circle. So you can replace x in this equation for the unit circle. Look at this, and they call this Pythagorean identity. And someone will say, and why not square on the entire thing by here instead of just the cosine? Let me turn on the page. And then the exercise are like, that's it. And then they go big time on cosine and sine. And for the time being, it's ideal to know well, we are not concerning with such calculations. Yeah, here there are some graphs for sine and cosine, but they have left alone the circles. So we are done with this book for the time being. Let's open some book on algebra dealing with circles. Sorry. How much time do we left? 41 minutes. Yeah. Yeah, pure theory this time around. I don't know any good books. We need to find a good book and then let's see if it is in the Internet Archive. Algebra and trigonometry. Well, we have this. Problem with this is that uh, they should include a dark theme in here. Again, the unit circle. Well, the unit circle. Now we know. Now we know this. But we should be able to, um, uh, for other. Mhm. Did you memorize this? If cosine is x and sine is y, it should be 0 and 1. Here it is, 0 and 1. Well, 90 degrees. Then I have the question on why is only to cosine and not to t theta. Well, how can I make this question? Maybe on math stack exchange. But they will say learn you some good algebra, which I will do later. Uh, so I will read the book on algebra and then see if I can see why it's not applied on t, only on cosine. If x is cosine of theta and not only cosine, the function. How can I get rid of this? They should put an x over here. This is invasive. You can derive all these things on your own by spending the entire day on these subjects and years, unlike the guys in the past. Believe me, you are very equipped in the brain to do all of this on your own and develop all the technology that has been developed on your own too. But it will be years and explorations. And the good thing about this book that is free is that there is a lot of exercises. Look at this. How many exercises are here? How many exercises are here? But do they have answer? And if there is the case, we can tackle algebra by itself, algebra book, just algebra or arithmetic, find a lot of exercises for us to tackle through the day. And maybe I will do that. Uh, so I will say, hey, come on, you're a software developer. Stop the mathematical thing and deliver the software. Well, I like these things. So do the reasoning. Mathematics is also about reasoning, and then go and spend some time in the mechanical part of mathematics, which is solving this stuff. Balance the two sides, the reasoning and the mechanical thinking. Okay, let me see if there are books on algebra. Algebra. And they have a lot of sciences here. I already knew about this. Don't think this is the first time I'm seeing this this website. Well, it's good that I have encountered again and again. So they do have acknowledged algebra. Contemporary mathematics. That's a new branch for you to tackle. If you want to know all the mathematics, includes contemporary mathematics. Elementary algebra. Oh, maybe this is for us. Pre-algebra. We need this. Oh my God, I love these books. Not these books. I love books. Just seeing the books, not reading the books. Okay. People producing knowledge. So let's take a look at pre-algebra or pre-algebra or whatever, because I need some arithmetic. The properties of real numbers. Okay, I will do this later. Where's the up table functions? Oh, a lot of functions. I would like to tackle this. Yes, that's for sure. Exponential and logarithmic functions. The unit circle sine and cosine functions. Periodic functions. This was in the book. Also, the entire axis are rotated. You know, oh no, I think we are going too far in here. Uh, I think for us it should be. Uh, I don't know. I think our problem is simpler. I'm going to delete all of this because know this in your, you know this in your heart. That's not the way to say it. For us, it's quite simpler since we now know about the unit circle and how the thing is related, all the equations that we have written. Now we need to, yeah, we need to, you know, for the things to work with bigger circles, finding these coordinates, and for the thing also to work with circles over here. You see? First, I would like to know how can I find this 0, 3? When we solve this, which probably that should have been done today, uh, then about this, finding this point. Maybe this is 3, 4. I don't know how to proceed. I think we are lost because this seems like too much. So we need to, I need, we will spend a lot of time here. I will read the circle section on geometry to to acquaint myself again with the terminology like central angle and how the arc length is proportional to the central angle. There is a lot of information on that book from the point of view of the figure of the circle by itself. I will do that and then review some algebra books that contains equations of the circle, some problems related to circles. And someone will say, then why you don't change the title of the live coding and write educating again, educating myself with elementary mathematics, high school mathematics, and avoid this clickbait that you are coding or programming. Yes, I will do that. Now it will say building, building this application, and it will entail me the portraying of the documentation process, right? Instead of live coding. That was a little bit of, uh, I didn't see this coming. So yeah, I will change the title. Building projective geometry. Building Geometrikap. And that with that I can afford to read those books because I think this is too much. We will find the relationships between X and Y on rotation. So there is an I here. Probably this has to do with complex numbers. It's not complex number. It's theta y. Where is theta y here? Oh, times y times a I. There are two equations, and here they are. These are the equations of the rotation. But I still don't understand this. So, uh, even if someone is saying now you should apply these equations, I don't get the concept. I don't know how to apply this. So we will explore the circle uh, in the geometry realm, in the algebra realm, with the equations, and then maybe come back here. So it will take us like the next 20 hours. So these are the equations of the let but still there is no and this does not I don't see how this will help us. Just this is a different thing. Yes, this seems a little bit different. We have found a book on our internet archive. Algebra. Remember, we saw this and we saw it on the stack, opening stack. I wish I had bought one of these algebra books, the ones written in this fashion. A good one on algebra. I mean, the Hellman algebra book is great, but this is another style of writing in which they are into these calculations, and I wish I have bought one of those. Wait. I have came into my mind the idea that maybe we should multiply, but I don't like at this point. Okay, so let's go back. So for this we had 0, 1. Now we want 3. We will have to do several exercises. So the I think we will find more circles in these books, because if you say that if the radius, the original units, the unit circle was in this fashion, and then it was scale up, if you want, if you will, by a factor of 3, then this coordinate obtained by sine of y, sine of s will be scaled by 3. This will give you this number, but as I was telling you, we need to mm, mm, we need to keep digging into stuff in those books to see if we find a circle, convenient circle that gives us something like this from a given coordinate that we can work like uh, 3, 5 in order to apply this idea of how do you measure this up? Like, if the radius is 4 and the center is not at the origin, I am certain these books has these sort of exercises. So we will. That's what I'm saying. I need to take a look at the circle section in the geometry book, um, to familiarize myself with the terminology mm, and then some algebra books dealing with circles. I remember great training on Udacity, visualizing algebra, but I don't remember if they have a section on circles. Right, so because now we have a coordinate here that we want. Oh, yeah. Yes, we will need to we need to familiarize ourselves with this figure because eventually we will tackle this Euclidean geometry in the future. So in here they go right ahead and say find the equation of the circle with radius 3, and then there is this distance formula from early chapter. Mm, this thing is something like this. You have one point here, x, xy, and then you have another point here, x1, y1, x1, xy, x1, y1. And then you want to measure the length of this segment or the distance between these 2 points. And they come up with this triangle, right? And then they arrive to the conclusion that the formula is the one you're seeing here. Well, they are using 2 and 1, right? So for us, it will not be 2, it will be 1. If you want to know why, it has to do with this, what they call Pythagorean theorem. You are seeing it right here. So that's the distance. And now they are applying it to the circle because they say the origin is here and all the distances from all these points. That's why the equation of the circle looks like this. If it is at the origin, right? And look at this. The circle might not be centered at the origin as seen in the next example. But I really have to, I really want to know why we are not able to apply that. How can we transform those things to give us two? If we go back with the rotation, the open stack. Mm, okay, so they say that for y it should be sine of theta plus, oh, there are some multiplications in here. That's the problem because you want to find the coordinates. You don't have the coordinates. Yeah, I think next the next week will be all about mathematics of the circle. I have skimmed a lot of training in my life. I'm trying to remember if I have solved this early in some computer graphics from edX or linear algebra training from edX also. There are matrix rotations that I barely remember. I'm not close if we have to represent the thing with matrices and apply some stuff. Um, so we will be exploring this training. And I don't remember all this. Uh, oh my from linear to frontier. I don't remember a lot of years with this. And by the way, this is free, but you can donate if you want. But these are vectors, and how we can represent? Oh, we can see these coordinates as a two vector, two component vector. Uh, okay, and look at this. It has the link to the YouTube video. This is great. Great resource from these guys. It was available on the text. and it's free to download, but you are invited to donate. You name the price. But yeah, this is a scaling the vector, for an alpha scalar. But they're saying just the vector will have the same magnitude, but we don't want that. We need the formula for the rotation. That's good properties for that you want to maybe take a look. But come on now, tell us the thing, how this thing works. Okay, now they go to reflection and they forget about rotation. Uh, Come on now. It cannot be that it's just studying the properties. Maybe, where is the other book that we found, the open stacks? Those I and J were vectors, and we have only two components, but time's up, I have wasted two of your hours. So maybe tomorrow, 2 hours again, more wanderings in this mathematics, maybe 3 hours. Mm, so we can include that 1 hour of the geometry, 1 hour of the algebra book, and 1 hour of this esoteric stuff. And maybe at the end, maybe it will turn out at the end that we just make this big detour to arrive to some simple formula, but it doesn't matter. Um, because I think session 3 hours minimum are needed for this to be serious uh, stuff. 1 hour counts. 1 hour counts, but for me it's just too few, too little time to really dig in. Like, is this the only? Okay, these are good properties, or maybe it's quite obvious and we are not able to see it. Okay, so yeah, those. but it should be, I don't know. We are tackling two problems. Okay, another interruption. Can you believe this? From what the paragraph says, there is a point in here, and the equation of the rotation, the equations of rotations, they say that to find the representation of this point xy, remember this point, to find the representation of this point xy on a new uh, axis, pair of axes that has been rotated some theta, in this case 90 degrees, to find this, and they give you the equations. That's one problem. But the problem that we were considering uh, is we have coordinate system, and we have a circle of any given radius r, when we want to find the measure the measure of this arc length. This arc length is defined by some theta angle. We want to find the measure of this length, the length of this arc length. Look at me. Look what an ignorant has to say about all of this. We are trying to find the length of this arc S in order to apply this trigonometric function and find this point. So this problem seems related, but there are different problems, but they seems very related. Okay, now we continue with the reading. If a point xy of the Cartesian plane is represented on a new coordinate plane where the axes of rotations are formed by rotating from the positive x-axis. We will need the contrary, so we have quite a lot to do. Then the coordinates of the point With respect of the new axis, x prime, y prime. And guess what? You will have to derive yourself because you know x and you know y. Maybe you don't know why, but you know why, which is here, maybe 0, 3. No, I mean 3, 0. You know this. You want to rotate this. Now you should be able to apply the thing to calculate this thing, but there is this by prime here. What's the point of these internet interruptions anyway? You know, I'm finishing this thing. Okay, but tomorrow we are going to, we're going to chill out and spend sometimes with the books we have been mentioning, some algebra, some intermediate algebra, some equations of the circle, some problems, basic problems with circles. And try to see what these guys have to offer. Maybe they are in algebra, maybe linear algebra. They have come up with some easier ways uh, to solve this rotation. Certainly, it's not here, or I'm not seeing it right away. So we have quite a lot to do. We're going to revisit Udacity Visualizing Algebra, which is on YouTube. And we are going to invest 3 hours. Uh, well worth 3 well worth invested hours instead of yes, Udacity has this content. I remember this equation on YouTube because you are unable to register for those mathematics and training, but they are on YouTube. Return the book. Don't forget to return your book. 2 hours and 20 minutes. Yeah. Mm, it's better for me to see some things offline about algebra. So thank you very much.